Alright, welcome back to the second video. In this video, we're going to go over 8.2, which has these two learning goals. Make sure those are copied down into your binder. We should have done that yesterday, though. So, today we're going to go over how to find the equation of a line so that it's parallel to another line, and also through a point that the book will give us, and how to find the equation of a line that's perpendicular to another line. So, this is back to our ramp situation where we're at the skate park. Here's the railing, right? Here's the skateboard that's going up the ramp. The person. I don't know how people look when they're on the ramp, right? But that's our ramp. Very short now that I drew the person to scale. But we can kind of see our ramp. So the first question asks, the equation of a line containing BD, which let's find that real quick. BD is right here. The equation for this line is y equals negative 2/3 x plus 4. So let's remind ourselves of the equation in slope-intercept form. And I should have wrote these on the chalkboard before I left. Slope-intercept form is our most popular form, y equals mx plus b. Right, we have our y value, which tells us, right, up or down. M is our slope, which we talked about yesterday about how to find. We have our x value, which tells us left or right. And then our b value, which is the one that we haven't talked about yet, is our y-intercept, right, which just tells us where to start at. So now if we look at this equation, we have all those parts, right? We know m is equal to negative 2/3 and b is equal to 4. So now we just have to remember the book wants us to identify the slope and identify the y-intercept. Sorry about that. So now we can just label. We know m is the slope. So our slope is negative 2/3 and our y-intercept is b, which is positive 4. If you're stuck, please write y equals mx plus b right above the equation you see, and you should always see that m is right next to x, and b is the number being added or subtracted somewhere else. So when we graph this, just as a little extra information, we take our b, we put that on the y-axis, and then we use our slope. So we go down 2 over 3 to get to our next point, down 2 over 3 to our next point. We can keep going too, and if we go in the opposite direction, we want to do the opposite. So up 2 to the left 3, up 2 over to the left 3, and that will give us the line BD. Well, it gives us the line that BD is on. So just a little clarification about that before we move on. So based on your conjectures in item 4 from the previous lesson, what would be the slope containing of the line containing JM? So here's the line segment JM. We want to know what the slope of that is. So if we look at this right now, they look parallel. And in 8.1 we said if they're parallel lines, then they should have the same slope. Yes. So then our answer here is if our slope was negative 2/3, our slope here should also be negative 2/3. Use the formula for slope to verify your answer. So we need to pick some points off of this and actually figure it out. So if we look at b, which is easy because it's on the y-axis, and k, which is easy because it's on the coordinate points, we get 0, 6, and 3, 4. So we can find our slope, which is y2 minus y1, so 4 minus 6, over x2 minus x1, so 3 minus 0. So we get negative 2 over 3, which is exactly what we said we want it to be. We now want to identify the y-intercept of the line containing JM, use the slope and the y-intercept to write the equation. So here we have to look at our y-axis, right, our y-axis, and see where this line intersects it. That's that point right at J. That is J, which is 0, 6. We don't use both parts of it. We only use the y part of it. So B is equal to 6. That's our y-intercept. So if we plug in all of our information into our slope-intercept form, we replace the m with what we said it was, which was negative 2/3. And then replace the b with what we said it was, which was 6. So this is our final answer for number 3, negative 2/3 x plus 6. Lastly, the book asks if JM is perpendicular to RJ, identify the slope, y-intercept, and the equation for the line containing RJ. So let's just look at our diagram real quick. All right, let's just find JM first. JM is right here. We just looked at it. And then next, RJ is this line right here. The book tells us that they're perpendicular, so that means their slopes are opposite reciprocals. So that could help us out here. We already know the slope of JM. We said that was negative 2/3. So we want to find the opposite reciprocal of that. So opposite reciprocal, we need to flip the fraction. So we get 3/2. It's already negative. So the opposite part would be to change the sign. So it's negative. We want to make it positive. Except for in math, where it's not negative, we don't need to write the positive sign. So this is our slope. If we look at the line RJ, we can see if it already crosses the y-intercept for us, which it does at J again. So that means 6 is the y-intercept, which we said was B, right? Slope is M. And now we want to plug it in and find the equation. So again, we have y equals mx plus b. And then we can plug in our values for m, which was 3/2, x, and then plug in our value for b, which was 6. So here's our final equation for number 4. And then we need to now argue about why they're perpendicular. So the book said if they're perpendicular. Now we need to check. So we can't use our equations because we used that fact that they're perpendicular to find the slope. So now we have to go back to our picture. If we find the slope using these 2 points or just the graph itself, we go up 3/2. So 3/2, which is exactly what we said it should be. So yes, since the slopes from the graph are opposite reciprocals. All right, so that's the gist of it, using the slope and the y-intercept from a graph to find the equation of a line. We're going to get into some more complicated stuff when we have the slope and just a point that isn't the y-intercept, and when we have the slope and a or if we're just given 2 points. So now let's move on to the next page. We're on page 93 now. When we look at this, we are drafting a angled grind rail, right? So that means the skateboard is going down the rail, someone's standing on the skateboard, having a blast, grinding on this, maybe making some sparks coming out of here. I don't know what they do, but that's what the grind rail is for. So they're designing this, the drafter, right? A drafter is just a technical drawer. person like an architect, they have a drafter or they are their own drafter to actually draw the blueprints. So drafter is just a technical drawer, and we'll be getting into that when we start doing our next unit on the computer. So the drafter has already drawn line N. So that's our line that's on the graph. Next, the drafter needs to draw line P so that it is parallel to line N and passes through the point -2, 3. So let's find the stuff on our graph first. -2, 3 is this point right here. And we want to draw the line parallel. So we know it should look something like that, right? But now let's actually be a little bit more precise and use the picture of the graph. So it asks, what is the slope of P? Right? We use our keywords here, which are parallel and passes through the point -2, 3. So since we want to draw a line parallel to N, if we can find the slope of N, we can use that and our knowledge from 8.1 to find the slope parallel to it. So now let's look at this. Here's 1 point, and then it doesn't get up to the next point until here. So that's rise 1 goes over 1, 2, 3, 4, 5, 6, 7, 8. So it runs 1, goes over 8, so our slope is 1/8. We could have also figured that out by using the point. So this is 2, 0. I'm sorry, 0, 2. So we would have done 3 minus 2 over 8 minus 0. So again, 1/8. So our slope is 1/8. That's for N. For P, since we know we want a line parallel to N, parallel lines mean the same slope. All right. So now the M should also be 1/8, and our how do you know is because the lines are parallel. All right. So now we want to write the equation written in point slope form. That's a new way to write it. So we have this equation over here. We have y minus y1 equals m times the quantity of x minus x1. So we need to know m, which is the slope, and we also need a point, x1, y1, that we want the line to go through. So point that we want the line to go through. We usually don't keep our lines in this form. We then distribute the m and get the y by itself and combine like terms, so that way we're back to slope intercept form. All right. So now let's do this. We're going to use our form. So we have y equal, no. We have y minus y1 equals m times x minus x1. We have our slope, which said was 1/8, and we have our second point. Well, we have a point, -2 and 3. So that means x1 is -2 and y1 is 3. So we can plug all this information in. Y stays y, but then we subtract 3 from it, because that's what y1 is. We know our slope, that's 1/8. X stays x, but then we subtract our x value, which is -2. So we can clean that up real quick. Y minus 3 equals 1/8. Quantity of x plus 2. This is when this type of math is going to get a little bit messy, because we have fractions. We have y minus 3. If we distribute that 1/8, we get 1/8 x plus 2/8. So now we can add 3 to both sides. So we have y equals 1/8 x plus 2/8 plus 3. We want to combine these two terms because they're both just numbers, right? Sorry, this is our answer just for B, and now we're doing the work to get us to C because we want it in slope-intercept form. So we want to combine these two terms. We have two ways. We can convert each to a decimal, so we get y equals 1/8 x plus 0.25 plus 3. So then we get plus 3.25. That's one way to do it. Some of our fractions don't convert to decimals easily. So if we want to add 2 8s and 3 together, we need to put the 3 so it also has a denominator of 8. So remember how we do that? We want 8 to be on the bottom, so we do 8 times 3 to get what number is actually on top. So that's 24. So we add those two together, we add the tops, the bottom stays the same. So 3.25 is the same thing as 26 over 8. So if we didn't want to write that as a decimal, we could write y equals 1/8 x plus 26 over 8. All right. This is not going to be an easy line to draw on the graph, which is the next thing, because we need to go to 3.25, which is our y-intercept. And then we also have a second point, so we can just use a straight edge to connect those to draw line P. All right. Sorry about all the coughing. That's example problem number 6. We look at problem 7, it's going to use the same graph, so unfortunately they didn't give us another picture. So let's try to use this without the picture, and it'll actually challenge us a little bit more. So if we read our problem, we want a line that is perpendicular and also goes through the point. So we have all the information we need, right? On the other problem, we said we need slope and we need x1 and y1. All right. We can do our point real quick, right? We have -9 for x1 and 7 for y1, but we have to do a little bit of work to find our opposite reciprocal. The slope, we want it to be perpendicular to n, and we said the slope of n, if we go back to the other page, we said the slope of n was 1/8. So the slope perpendicular to that, we would have to find the opposite reciprocal, which means we flip the fraction and make it the opposite sign. It's positive right now, so we need to make it negative. And we can rewrite that as just -8. If we look over here at the math tip, it says opposite reciprocals should multiply up to -1. So if we want to check that, we can. 1/8 times -8 over 1. Right, we can multiply across. That's how we multiply fractions. So we get -8 over 8, and that simplifies to -1. So that's perfect. So we know that is the opposite reciprocal. We checked our work. So now we want, we found the slope. Keep doing too much work too early. That's the slope because it is the opposite reciprocal of the slope of line n. Point slope form, which is y minus y1 equals m times the quantity of x minus x1. That information is all up here. So we have y minus y1, which we said was 7, equals -8 times x minus x1, which was -9. So let's clean that up. So we have -8 times the quantity of x plus 9. This is our answer because that is in point slope form. We want to put it in slope intercept form. Now we need to distribute and get y by itself. So if we distribute, we get y minus 7, -8x, and we need to multiply both things inside the quantity by -8. So we get -72. That is a huge mistake that people do, is they forget to take the negative as well. Right, so this should be -72, not +72. We need to combine, we need to get y by itself, so that means we need to add 7 to both sides. So we get y equals -8x minus 65. That is our answer in slope-intercept form. Again, though, we have a weird y-intercept. So if we go to graph this, -65, the smallest number we have is -2. So the easier way to do this is to remind ourselves of what that point was. So we wanted this perpendicular line to go through -9, 7. Right, so we wanted to go through this. I'm going to change color again so we can see it a little bit better. We want it to go through this point, and then we also want it to have the slope of -9. So we go 1, 2, 3, 4, 5, 6, 7, 8 down, and 1 over. So instead of having to actually go down to negative 65 for our y-intercept, we can just use the point that we know it has to go through and then the slope to graph it. And this was line Q. And we can see that this does look pretty much 90 degrees. So the next thing will be, finally the drafter needs to draw a line R so that it is perpendicular to N and passes through the point 80. All right, so try this one all on your own. Pause the video for real. Come back to me in a second. All right, cool. I'm going to go through this real fast. All right. Our original slope for N, we said, was 1/8. So again, we have the word perpendicular, so we need to find the opposite reciprocal. We already found that, and that's -8. But now we have a new point, 80. So let's put this in point interslope form real quick. Sorry, point slope form, so that's y minus y1 equals m times the quantity of x minus x1. So we do y minus, our y1 is 0, which is going to be lucky for us. We know the slope, so we should plug that in, which is -8. And then minus our x1, which is 8. So we always want to simplify. We know what -0 is. It doesn't change anything. So we can just make one side y, clean that up. And this is our answer in point slope form. Slope intercept form is when we clean it up and get y by itself. Y is already by itself. So all we actually need to do is distribute that -8. So we get -8x, and this is where I foresee most of us making our mistakes if we made a mistake. We have -8 times -8, so we actually get positive 64 for our y-intercept. So again, we get this weird problem where our y-intercept is crazy different than what's on our grid. So we wanted to graph this. Instead of finding 64 on the y-axis, let's use that second point. So we want it to go through 80, and then we knew our slope was -8. We can't go down and over because we run out of space, so that means we have to go up and to the left. So we go 1, 2, 3, 4, 5, 6, 7, 8 up, 1 over, so that's the second point on the line. And then here is the line R. And again, it does look perpendicular. It's also perpendicular to the other line that we were given N. So we did a good job. All right. Check. Cool. We just have a couple more problems to go through. Hopefully you are catching all this. Again, tomorrow on Friday, you'll do the worksheet. And then on Monday, you get to ask me questions. Now it says describe the relationships between N, P, Q, and R, those lines. So this means decide if they're parallel, perpendicular, or just intersecting. All right, so if we look at this, N and P, we can go back to our graph and see this, or just use our slopes. So let's just do that real quick. The slope of N was 1/8. The slope of P was 1/8. The slope of Q was -8, and the slope of R was -8. So now we don't have to use the graph since we have our slopes. N and P were parallel. N and Q, if we look at their slopes, they're opposite reciprocals, perpendicular. And then lastly, N and R, they are also perpendicular. So now let's look at P. We already did P and N, so let's just do P and Q. If we look at their slopes, they're opposite reciprocal, so perpendicular. P and R, if we look at their slopes, they're opposite reciprocals, so also perpendicular. And then lastly, we look at Q. We haven't compared Q and R yet. We look at their slopes, they're both -8, so they are parallel. So we have 6 relationships we can say. If we look back to our graph, we can see that that makes sense. We did form like a rectangle right in the middle, and we can make those 6 relationships that hopefully you understand how I wrote them using our symbols. So quadrilaterals can be classified by the presence or absence of parallel lines and by the presence and absence of perpendicular lines. So I already said this, I forgot this was a question, but if we look back at our graph, it's asking you, which I had a hard time understanding what this question was asking. It's asking you what shape is formed by these four sides. So like what shape am I coloring in right now? I already said it, but we have right angles and parallel lines. So this shape would be a rectangle because we have four right angles, two sets of parallel lines, but all sides are not the same length, which for the square it has to be. So we know this is definitely not a square, but rectangles are the other shape that has right angles at it. All right. Part of your work tomorrow would be doing 3 through 5. So try 11 and 12 right now, and I'll tell you the answer in the video just in a second. All right. So you should have paused it. Welcome back. Second chance to pause it if you didn't actually do 11 and 12. All right. Welcome back. So let me add a new page. All right. So let's go back and look at what we need to do. We need to find a line that is parallel to this equation. Doesn't tell us anything more specific than that. So our original equation, this was number 11. Original equation is y equals 5x. Sorry, y equals 4 over 5x minus 7. And we want a parallel line to this. Doesn't give us a second point though that it has to go through, so we can make up our own. So if we look at this, the most important thing is since we know we want parallel, we have to take our slope, which was 4/5, and use that. Parallel means our new slope, right? Our new line, our new slope should also be 4/5, but our y-intercept, it literally gave us no other constraints, so our y-intercept could be any number. So your line could be y equals 4/5 x, right? And it kind of has that plus 0, but we don't really need to write plus 0. It could be y equals 4/5 plus 2, y equals 4/5 x minus 3, and so on. The list goes on. You can come up with anything as long as the slope is 4/5. You are good. You can have any value of b that you want. Same thing for 12. It didn't tell us the point it has to go through. Just told us it's perpendicular to negative 2x plus 1. So if we go back to our blank page, 12, we want it to be, here's our original line, negative 2x plus 1. We want a line that is perpendicular all right, so we always have to use our slope for this, so we need to pull out our slope. The slope was negative 2, so for our new line, our slope should be the opposite reciprocal, which means we flip the fraction. Negative 2 isn't a fraction, someone might say. Let's make it a fraction by dividing it by 1, so we flip it. So we get 1/2. The original slope was negative, so our new slope should be positive. But we don't need that because any number that just doesn't have the positive sign is still positive. So we know our slope is positive 1/2. So just like before, we don't need it to go through a certain point. So as long as we have 1/2 x and then any number after that, so plus 1, y equals negative, y equals 1/2 times x minus 1 or anything. Seriously, any value of b would work. All right. Again, 13 through 15 are in the worksheet tomorrow that you have to do. But as a reminder, take this math tip serious, and I remind you on the worksheet itself tomorrow. But you are getting asked to describe the lines below, right? So I'm asking you to do just like what we did up here. Do this for number 13. So find the slope of each. That's all you need to know. You don't even need to write a whole equation for this. Just find the slope of each. All right. 14 is asking you find the slope of a line parallel to, you need to figure out if this is a horizontal or vertical line, right? And then find the slope that is perpendicular to that same line. It's going to challenge you, is this y equals -3, is that a horizontal line or a vertical line? If you get stuck, you can use your phone as a graphing calculator. Go to desmos.com, graph y equals -3. You can compare that to x equals -3, so you can see which one's vertical, which one's horizontal. And then lastly, for 15, suppose you are given an equation of a line and the coordinates of a point not on the line. Walk me through the steps. Go step by step and tell me, how do you go through that process? I did tons of examples for you today. You can find more examples at Khan Academy, which is what you should be doing if you finish these notes and you still have even just a minute left. Go on to Khan Academy and try one problem or watch a little bit of another video. All right, I'm looking forward to hearing back from you, hearing back from the sub, and seeing what you get done on the worksheet tomorrow. So again, you'll get a notification tomorrow about what your homework is, what your classwork is tomorrow, what you're going to get a worksheet where you have to do all this work all over again, finding lines, the equations for different lines that are more like the work that we did for 6, 7, and 8. All right, good luck. I'll hear back.